Hi, and welcome back to helper videos for the exponential functions test for do-overs or preparation for future ones. This question is very similar to number 3 on the 2019 April exponential functions test. Here we go. We have a situation in which you drank too much coffee at a moment of very poor choices. You haven't had any since your initial consumption, and your very jittery body has gotten down to 1,000 milligrams of, that should not say coffee, that should say caffeine. I'm glad you gave me an opportunity to edit my work here. Don't do this to yourself. The biological half-life of caffeine is 5 or 6 hours. I've given you two amounts of time, so you can expect you're going to be getting a high and low number for everything. All right, so we know an initial amount of, well, we know a current amount of caffeine in our body, and we can treat that as an initial value, and then it's a half-life, so our base is going to be 1/2. So let's go ahead and start off our equation. Y, our output, equals our initial value of 1,000. We'll use that as the initial value times 1/2. And then we're going to raise that to, we're going to decide what our x is going to be. Our x is going to be hours in this case. Everything in this problem is going to talk about time in terms of hours. So it's going to be either x, it's going to be x over the length of the half-life, which means x over 5 or x over 6. So we're going to do both. So x over 6 for the long half-life, and y equals 1,000 milligrams of initial value times 1/2 to the x over 5. So those are going to be our basic two equations that we're working with. When we get to part A, we want to find out how much caffeine is going to be in our body in 10 hours. So we can take these functions here, and 10 hours is just what x is. So we can replace x with 10 in both cases, and it'll give us an output for y that will tell us how much caffeine is in our body in 10 hours. So let's go ahead and do that in Desmos. So I'll go there, go to Desmos, and we'll say, okay, y equals 1,000 times 1/2 raised to the x over 5 for the short half-life, and the same thing, only raised to the x over 6 power for the longer half-life. Okay, I am way too zoomed out now, so I'm going to zoom in and zoom out just a little bit now, and you can see our two tracks. Okay, so if I copy this one down here and I replace x with 10 hours, it tells us we'll have 250 milligrams of caffeine in our system. If I go to the x over 6 version, I replace x with 10, I'll have 314 we'll round that to 315 milligrams. So there's our answer. We're going to have on a low end of 250 milligrams, a high end of 315 milligrams rounded. I could have also done this by saying x equals 10, and then I would see where this function intersects. I'm just going to have to move the function until I find the intersection points for my two thing here. This is right there, 250 and 314. Okay, oops, that's the wrong one. Get rid of that. This function here. Yeah, there we go. Get rid of that. So it's 10 hours in the future, 315. I apologize for these extraneous things here. 10 hours in the future, 250 milligrams if it's leaving your body faster. So that's our answer. And we go back to our question and we say high amount of 315 milligrams for slower half-life, or should I say longer half-life. And low amount of 250 milligrams for the shorter half-life. Okay, cool, we've got that. Now we want to know what time it will be. Well, what I really mean here is how long from now. How long? I should change that question to, if I'd given you an initial time, what time would make sense? How long from now will it be when we get down to 20 milligrams of caffeine? We'll give a high and a low time. So for that, instead of seeking an amount of caffeine, we want a time. Time is an X value, so we've been given a Y value of 20 milligrams. So we're just going to go into our Desmos again, and we're going to create a horizontal function at Y equals 20 milligrams, and we'll go back to Y equals 20. This is Y equals 20 right here. And we're going to click on both the quicker departure and the slower departure. So if we're having caffeine leave our body quickly, then it's going to be 28.2 hours. If it's leaving more slowly, 33.9, I'll just say 34 hours and 28 hours. So 28 hours to 34 hours is our low and high time. So 28 hours is the low time, and 34 hours is the high time before you're going to get down to 20 milligrams of caffeine. Okay, the final one gives us a time, and we want to know how much caffeine. So we've been given an X value. So we can take this function and this function, copy pasta that, and instead of 10, we want 15 hours ago, which is going to be a negative 15. So negative 15 and negative 15. We go right back into Desmos, copy this one, like that, negative 15. We had 8,000 milligrams 15 hours ago. Whoo, you are almost dead back then. Now let's try, I'm just going to change this to negative 15. I know my half-life is wrong, so we've changed that to 6. We had 5,650, we'll round that to 7, 5,657 milligrams. Still, you're probably in the hospital with either of these numbers. So don't do this. Don't try this at home. Don't try this anywhere, ever. Don't do it to yourself. Even if you're in college and you're doing an all-nighter, don't do it. Don't do it. At any rate, this is what the answer would be for the high amount, and this is the low amount. So we go in here, say high amount of 8,000 milligrams, low amount of 5,657 milligrams. Double check that number. Yes, that's what I had rounded. And that's your answer. Now, I could also have solved this by saying, okay, X equals negative 15, and I would have gotten intersections way the heck up here. I have to zoom way up to get into the 5,000 and 6,000 range. And here we go. It's going to be a little hard to see where it intersects, but right there, that's 15 hours ago on the slower one, and we zoom way, way up there to the 8,000, and 15 hours ago, we had 8,000. And it tells me I'm running out of time, so I'm going to stop. I hope this was useful for you. Please feel free to send me emails if you have questions.